Okay, so we assume negligible friction and acceleration of, about halfway between these, 2.45 inches per count squared, negative 0.45, with V naught of, split the difference over here, 5.2 inches per count, okay? Then the question is, when is x of t 10 inches? Now, one person put the 10 in for the t without units. That's something that everybody's going to do at one point or another, in one form or another, at one time or another, if you're not really careful about putting down the units, okay? But that 10 inches is an x, it's not a t. So it's real easy to start throwing numbers into an equation and lose track of what they mean. So try to keep track of what all the numbers mean. But then, here's the equation, and it's very straightforward. We just plug in 10 inches for x and 5.2 inch per count for V naught and negative 0.45 inch per count squared for A. And here we have it. Okay? Now, are these dimensionally equivalent? Another thing, you better stop and check. I'm not real sympathetic if you don't when I'm grading a test, okay? I mean, the universe is not real sympathetic to mistakes you make. You crash your spacecraft into Mars every day, right? Reality requires checks, okay? So all these things come out in counts, in inches. This is in inches, so this had better be in inches, and this had better be in inches. Is this going to come out in inches? Well, yeah, it will if t is in counts, right? Okay? Is this going to come out in inches? If t is in counts, yeah, the counts will divide themselves out with the squared counts, okay? So you check out your units, and now you see that you don't have an error, okay? Okay. At that stage, you can sort of just deal with the numbers because you know that you're solving for t, which has to be in counts. Okay, to make the units consistent, t will be in counts. So t equals negative 5.2 plus or minus the square root of 5.2 squared minus 4 times negative 0.23 times negative 10. Yeah, that's going to work. For a minute there, I thought I was going to get a negative. Just I wasn't looking at it, bad angle. And, brain's not totally engaged, I guess. So, and that's over. This is going to give you two results. Now I'm going to just kind of guesstimate this. That's going to be 40, and 40 times 0.23 is 111. 4 times 0.23 is 9.2. That's about 27. 27 minus 9 is 18, 17.8, about 4.2. So the square root there is going to be about 4.2. And you're going to have then it's too much to keep in head. 4.2 is going to be negative 9.4 over that. Okay, 4 times 9.4 is about 18. That's very approximate. Or 1.2 over, that would be about 3. Now, you can refine that, but that seems about right. Okay, seems reasonable. I don't know about that 18, I'm not sure I like that. Anyhow, work it out. And what's that tell you? Tells you pretty quick going up, after about 3 counts, you're 10 inches along, you're about a third of the way up. Okay? And that's not quite right. It should be a little more than that. Maybe about 5. And then at 18 seconds, after you've gone up here and stopped around 11 seconds or so, 11 counts, it comes back down, and when it hits about 18 counts, you're passing it again. Okay? This smaller number, you're passing it in the positive direction. The larger number, you're passing it in the negative direction. If I further ask, what's the velocity when x equals 10 inches? I believe that's one of your equations. If it's not, you find another one. Your velocity is going to be 5.2 inches per count. Plus your negative 0.45 inches per count squared times t. So to take about 18 counts and to equal about 3 counts. Again, something my calculation went haywire there. But we're going to use these numbers, okay? And you can correct them. And I got right, so their V of 3 counts is 5.2 inches per count. And I'll just write negative 0.45 inches per count squared times 3 counts. Okay, well that comes out 1.35 inches per count squared. We'll call it 1.4. And with that, it's going to give us 3.8 inches per count. Okay, 0.45 times 18 is 10% less than half of 18, which is 10% less than 9, which is like 8.1. I'm not that far off in my estimates. say you get negative 2.9 inches per count. Okay? Now, if we use accurate t-values, because these are only approximate, those velocities will be equal and opposite. Reason for that is the equation here gives you a parabolic graph. So if we do x versus t, we're going to get a parabola. You know from pre-calculus that you have a parabola from any quadratic function. So we're setting a quadratic function equal to 0. Okay? And gotta redraw it. That was a really pretty parabola. I hate to have to redraw that. There we go. I apologize, but okay, this parabola it looks a lot like what I did, but the x-intercept is negative 10 inches. I draw this parabola. I'm going to go back to my original parabola. There's going to be slight confusion either way I do it. I thought I was going to like this one better, but I like the other confusion better, so I'm going back to it. Sorry. So here's my original parabola. It's probably not going to be nearly as pretty. I always get my parabolas lopsided. Not too bad. Okay. Now what we're looking for is when x equals 10 counts, right? So up here is 10 inches, not counts. 30 inches. So 10 inches is going to be down about here. Right? And your quadratic equation sets this function, this one here, then I'll write as negative 2.3 t squared plus 5t. Okay? And that's set equal to 10 inches. Now what I started to do when I erased the original was do this function, okay, which subtracts the 10 inches, because of course we set this equal to 10 inches. You get this. You could do what I was about to do, but I'm going to stick with this because it's one step less confusing. Okay, so anyhow, there it is. Well, here's your time. And here's your time. I said this is approximately 3 counts. This is approximately 18 counts. From the way these numbers came out, I'm pretty confident that it's 4 and 17. Pretty confident, not going to bet the farm on it. Okay? These come from solving the quadratic equation, this function equal to 10 inches. And you need to understand that graphically as well as algebraically. The other thing is the velocity, and this is just a position versus time graph, just like the theta versus t graph you made for the beam. Okay? You know the slopes of that graph are the angular velocities, right? Just like the slopes of this graph are the velocities. And we spent some considerable time talking about how slopes represent the velocities. And the slope of the tangent line here represents the instantaneous velocity. Okay? So the slope here should be, probably going to split the difference between these, and you're going to get about 3.4. So the slope here should be about 3.4 inches per count slope. About negative 3.4 inches per count. You could also look at your velocity versus time graph, simple linear graph here, and you really ought to think about doing that. You want to understand this deeply enough to solve the trickier problems.